Hi, I'm Arnaud Vacheron, editor of the French website dedicated to machining and additive manufacturing, machinuti.com. On Formnext, 3D Systems has chosen to present two complete manufacturing cycles in additive metal fabrication, from the design phase to final machining. Mark Cook, Vice President Metal Product Management, accompanies us on the different stages of the process.
Hi, I'm Mark Cook. I'm Vice President of Metals Products here at 3D Systems, and really excited today to be in our booth here at Formnext, where we're showing for the first time a complete workflow of two example applications. And what we're seeing is additive manufacturing is moving more and more into a serial production environment. Of course, it's still used very broadly for prototyping, but more and more companies are interested they're finding applications that are really viable in a production environment. And so what we do at 3D Systems is we help customers develop the complete workflow for that application so that they're successful with the actual application and not just the 3D printing part. So here at Formnext we've set up our booth to demonstrate that workflow for two real-world applications, one in the aerospace sector and one in the healthcare sector. So here we are at the design phase of the workflow, and what we're demonstrating in this particular application is an aerospace bracket. This is used on a satellite, and so the first thing that we need to do is analyze the part for 3D printing capability. So one of the first things that we'll do is we'll have our Customer Innovation Center, our application engineers look at the part. They'll analyze it and they'll try to make a determination whether the part is suitable for 3D printing or not. So as far as design, we'll make sure that the part is suitable for 3D printing, and if not, we'll make recommendations on how that part might be better. If there are changes that are recommended, we'll recommend those changes. Anywhere from things like wall thickness, angles, internal passages, surface finish, or things that are difficult to print. We'll make recommendations on how to improve that design. So from design we move to build prep. So the CAD model is brought into 3D Expert. 3D Expert is our 3D Systems build prep software. It's an all-in-one inclusive. It's an all-in-one additive manufacturing software that does build prep, design, and slicing. So this is the same bracket that we prep for build, but in this particular case it's on what we call a mini pallet. So depending on the application, you might build multiple parts on a single build plate. In this particular case we're designing individual brackets on their own little build plate, and this allows us to, what we'll show later, allows us to post-process this bracket without losing any reference points. So in the build prep stage, we can bring a parametric model into 3D Expert. We'll build support structures. We'll orient the part on the build plate, and then we can also modify the part. So things that require post-machining. So surfaces and holes, for instance, we can add material without losing the original part CAD geometry. We can add that material that will then be removed in the post-process machining. So once the print job is prepared and it's ready to send to the printer, in this particular case, this bracket is sent to the DMP Flex 350, which is, you can see behind me here. So this bracket is, this machine is 275 by 275 millimeters by 420 millimeters tall. And so in this case we can do multiple brackets on each their own little mini pallet. What's unique about the DMP technology is the use of a vacuum chamber. So we use a vacuum chamber to evacuate all of the oxygen, and we get very, very low oxygen levels, down below 25 parts per million. And then because it's a sealed vacuum chamber, we're able to pump in inert gas after the oxygen has been removed, and that maintains a consistent low level of oxygen and throughout the build process. And it also allows for very low consumption of inerting gas. And in this particular case, where this is a titanium bracket, we use argon as an inerting gas. So another, I guess, other unique properties of the system are uniform gas flow across the surface to keep the fumes off the surface for a nice clean melt pool, and bidirectional recoating. So we coat from both directions. That improves the speed of printing. So from printing the part, we move on to inspection. Once the part is printed, one of the things that we do during the print process is we have a tool called DMP monitoring. DMP monitoring collects visual data and melt pool data every layer during the build. And so during the build, we have the ability to manually look at sort of visualize that data on the screen and make some decisions during the build about what's going on. But even after the build, we collect all of that data and we bring that back into our software, 3D Expert. We have a module within 3D Expert that's called DMP Inspection. DMP Inspection uses algorithms to analyze that data and highlight any potential issues that might have happened during the build. So one of the key attributes that we can look for is lack of fusion or porosity within the part. So the data that we collect during the build, we have algorithms that can actually correlate very well to CT scan data showing porosity. So we have on the screen here, we have a few examples of the actual bracket with the DMP monitoring data overlapping the build file. So you can identify things like surface dross, porosity, and other sort of areas of interest that you're looking for. Essentially, what that allows you to do is make an informed decision about some of your downstream processes. So if you want to minimize CT scan, cost of CT scan, if you identify things in DMP inspection that correlate with CT scan data, you can eliminate some of that CT scan cost. And continuing with the workflow, once your part is inspected, you want to prep that for further post-processing CNC machining. So again, using 3D System software, the Cimatron software and 3D Expert, you can prep your part for CNC machining. One of the things that's very important in order to really develop a good workflow that meets the needs of every application is to have good partnerships for all of the non-additive manufacturing part of the workflow. So we've partnered with GF Machining Solutions to help us with the more traditional parts of the post-processing. Everything from CNC machining that you see behind me to automation of the workflow. So the mini PAL concept, and what you can see in here, this is a GF Machining Solution, the HSM 200 Machining Center, but we have in the chuck we have the mini pallet with the bracket on the pallet, and it's being machined right on the pallet. So with the help of our partnership with GF Machining Solutions, as I said, we can do things like automate the workflow and add all of the downstream post-processing. So behind me is the GF Machining Solutions, the Cut AM 500, which is a wire EDM machine designed specifically for removing parts from additive manufacturing build plate. So what's unique about this is it's a high-speed horizontal EDM machine. So it has the ability to quickly remove parts accurately from the build plate. So there's no wasted material and no further post-processing once the parts are removed from the build plate. And what's also unique about this is because it's a horizontal cut, the parts can be fixtured so that when they're removed from the build plate, they're not damaged. So they fall into either a basket or a fixture that's designed specifically for that part. So another example of, in this particular application, the parts are removed from the mini pallet after they're machined. In some cases they're removed in bulk before they're machined, or if they're not machined at all, they're removed prior to machining. So the Cut AM 500 can be configured for any application that you have for sizes up to 500 by 500 millimeters. And so in the example behind me, we have both the aerospace bracket on the right, and we have some healthcare, some spinal cages on the left. So behind me we have the final parts that have gone through this entire workflow here, and each uses a little bit of a different workflow, but it's an example of how 3D Systems is working with customers to understand their applications, to develop the workflow that works for them to get their final part quality where it needs to be. It's an example of how 3D Systems and GF Machining Solutions have partnered to make sure that we have a full complement of the entire workflow. So we're able to solve whatever that workflow might require. So every workflow is different, every application is different, and 3D Systems is able to develop a workflow that works for each application.
Retrouvez nos actualités quotidiennes sur les machines-outils, logiciels, outillages et services sur le site internet du répertoire de la machine-outil, machine-outil.com, tout au singulier, et n'hésitez pas à me contacter sur LinkedIn.